Hello class, today we're going to discuss systematic explicit instruction, integrating 4 teaching principles into an instructional cycle, the 4 instructional domains, and strategies that coincide with each domain. Let's begin by discussing what explicit instruction is. Explicit instruction is a systematic or carefully planned direct instruction. This direct instruction creates interactions between student and teacher where the teacher is clear, unambiguous, direct, and visible with all of their actions. The goal is to have students ready to learn new material by already possessing a clear understanding of previously taught skills. There are 6 critical features of explicit teacher-directed instruction. The first is daily review of the previous lesson and any pre-skills for that day's lesson. Next is presenting the new content through modeling, demonstrating, asking questions, and encouraging active participation from students. After students have acquired this new knowledge, the teacher provides opportunities for guided practice, where the teacher is able to give positive and corrective feedback. Then, for any struggling students, the teacher can reteach. Independent practice is then provided for students to build proficiency and fluency. Lastly, teachers provide systematic practice, which may include weekly or monthly review to help students maintain learned skills. There are 4 teaching principles for integrating explicit teaching into an instructional cycle. The first is providing and communicating clear expectations for student performance. Next is providing structured student practice with carefully planned prompts. Then, throughout the lesson, teachers monitor student performance. And lastly, teachers provide both positive and corrective feedback. Now, let's discuss the 4 instructional domains, which are conceptual understanding, procedural knowledge, declarative knowledge, and problem solving. Hudson and Miller explain that, quote, each of the 4 instructional domains are essential individually in developing mathematics literacy, but the interrelationship is also dynamic, with knowledge in one area leading to gains in another, end quote. Developing conceptual understanding is critical because it provides the foundation for understanding. In order for students to be proficient in math, they need to be able to understand a variety of complex concepts and then be able to generalize these concepts to real-world problems and situations. These concepts all have characteristics that put them in a category which allow for students to make generalizations. When students learn new concepts, they can then apply them across other problems. Students can exhibit conceptual understanding through 4 cognitive processes, which are application, noting relationships, transformation, and transfer. Strategies for promoting conceptual understanding are using a compare and contrast structure, using an example non-example structure, or using a step-by-step process structure. It's also important to include various modes of representation of the concept that's being taught. Developing procedural knowledge is essential for many mathematical tasks that students learn to perform. This involves teachers developing a procedural strategy to solve a specific kind of problem. Hudson and Miller define a procedural strategy as, quote, a set of sequential steps that lead to the solution of a problem, end quote. Procedural knowledge is commonly used to solve computation problems. It is also needed for tasks involving making change, measurement, collecting and analyzing data, and solving word problems. One procedural strategy is solve. This strategy involves setting up a problem to solve, which includes reading the problem and identifying the sign, attacking the problem, which is performing the steps to solve, and lastly, wrapping it up by checking your answer. Another procedural strategy is draw. This strategy involves discovering the sign, reading the problem, answering the problem, typically by drawing, checking your answer, and then finally writing the answer. Declarative knowledge is all about students retrieving information that they have memorized without any hesitation. Declarative knowledge involves a lot of practice and develops fluency and automaticity of math skills. Students are able to experience success and progress through curriculum as the skills build on one another and become more complex. One instructional strategy for promoting declarative knowledge is constant time delay, where the teacher provides a prompt when a student fails to respond within a few seconds. These prompts allow for direct, systematic instruction with immediate feedback and reinforcement. An example of constant time delay is flashcards. Prompt fading procedure is another strategy where the teacher controls a stimulus to increase correct student responses, but prompts are faded out over time. 1-minute timings can also be used to develop declarative knowledge. It's important, though, to set a goal for the student to master, which will promote motivation and provide opportunities for success. Problem solving is equally as important as the other 3 domains. Problem solving is about students applying previously learned knowledge, skills, and strategies to solve problems. It involves analyzing to identify and design solutions that require high-level thinking. Logic and reasoning are also often needed to solve problems both in math and daily living. Developing problem-solving skills is important for students to be successful in today's world. One strategy for teaching problem-solving is using anchored instruction. Anchored instruction is the use of video-based problems. These types of problems engage students in authentic situations while they use previous knowledge to help solve the problem. Another way to develop problem solving is by using procedural strategies that we previously discussed. These procedural strategies help students to solve word problems. The strategies are systematic and help cue students' thinking. Schema-based instruction uses schema diagrams to represent different types of word problems. It requires students to be able to determine the schema, extract information from the word problem, and appropriately place that information into the diagram to solve. In conclusion, all 4 domains work together to create complete mathematic competency in students. Teachers use explicit instruction to develop these skills and strategies, making sure to incorporate the 4 teaching principles to help their students be successful. Here are my references, and thank you for listening.